So children, we had done about line symmetry. Now we are taking point symmetry. See what is point symmetry? Let's learn about it through the video. Let me increase the volume. See, lines of symmetry are these for these objects. We are having the vertical axis, and then see there are also lines of symmetry for this. So line that revolves this figure. We have done linear symmetry in all these things. What is point symmetry? See, for this all things we have done. So a line that divides a figure into two equal halves is called as the line of symmetry. But if you talk about point symmetry, it says point symmetry exists when a figure is built around a single point called the center of the figure. Okay? And from every point of the figure, there is another point found directly opposite it at the same distance in every other side of the center. Okay? This is what point symmetry is. See more things. So see what it says. Point symmetry exists when a figure is built around a single point called the center of the figure. So for all the objects in which there is point symmetry, there will be a center, and around it will be symmetrical. For every point in the figure, there is another point directly opposite it on the other side of the center. Now this is the definition part. How you understand point symmetry? Let's see more. See, this is a rectangle ABCD given. Okay, now what? Now if you are drawing a diagonal, it's AC and then there is diagonal BD. Okay, these are diagonals. Now these two diagonals intersect at the O. O is the point of intersection of the diagonals. Already we have talked about quadrilaterals also in understanding the shapes. Then what next? If you are taking any point P on the rectangle ABCD, on this rectangle we are taking point P, random point. From P we take a point P on this rectangle and then we are producing the point backwards till it meets the other side P dash. So now P is a point randomly taken and then P dash is the production of the point P on the other side. That means from point P we take a scale and produce it backwards such that it strikes on the opposite side at P dash. Now what? After making point P dash and P, join them with a broken line. Then what next? Now if we measure the length of OP dash and OP, we find that both the length line segments will be equal. What does it mean? Does it verify the definition already told? I am again telling that point symmetry exists when a figure is built around a single point called center. So if we assume O to be the center, then for every point in the figure there is another point directly opposite. So what? For every point P. So in this figure we have taken the point P. For this point there exists another point opposite to it. Is it that? So can I say P dash is the point opposite to O or opposite to P, and they both are at same distance. See? At the same distance from the other side. This is what point symmetry is. So thus P dash is directly opposite to P. I hope it is clear to all. Now, so initially we had talked about line symmetry, two lines of symmetry in the rectangle, one which is passing through the parallel to this length and one which is perpendicular. Two lines I had told. Now there also exists point symmetry in the rectangle. Okay. So our figure can have many types of symmetries. Linear symmetry we have discussed already in the previous lecture, and now point symmetry also I told you how the definition is being verified here. That also we have seen. So rectangle has got point symmetry about O. Always point symmetry is about the point only. From that point, the distance from this point O from P is same as the distance of O to P dash. If that is equal, then only we say that this figure is symmetrical about this point O. Next what? Now see, there is rotational symmetry. Now what we have done? We have taken this figure and rotated it through 180 degree. See, B which was initially here. If we rotate to 180, what will happen? 190, B will come down. And then if we again rotate, it will come up. That means from here to here, 90, then this. So see, B which was at the bottom has come at the top. That means this whole figure is rotated by 180 degree. Now what? Does this, if we exclude the shape, which is not shape, the labeling part, if we exclude the labeling part, B which has got inverted A also, other than that, the figure was a rectangle initially. After rotating through 180 degree, is it still a rectangle? It is. So what happens? It means that even if we are rotating it, the figure remains in its original shape. So that's what is point symmetry about. I think so point symmetry is complete. Let's learn something more also. So a figure has point symmetry, it has rotational symmetry. So if a figure has got point symmetry, it will also have rotational symmetry. There is something more also about it. We will learn it in the same lecture only. Let's learn about rotational symmetry now.
In this module, you will learn about rotational symmetry. Does the giant wheel look different where it rotates? Actually, it looks the same at every position.
See, it is saying what? The giant wheel on rotation, does it look the same at all points? It does, because it has got rotational symmetry. That means if we are turning it through any angle, it still looks the same. And one aspect of it, just how we have learned in point symmetry also.
A giant wheel looks like one big circle, no matter through what angle it has been rotated. We can say that the giant wheel has rotational symmetry. Any object or shape is said to have rotational symmetry if it looks the same even after it is rotated about a fixed point.
Okay? So that is what it is saying here, that object or shape is said to have rotational symmetry. That means if an object possesses rotational symmetry, even if you rotate it through any angle, it will look the same. That was true for the giant wheel. And again, these definitions could be asked for MCQ type questions. So you need to learn that. And now see, it is showing the angles through which the objects are rotated. And even after rotation, the figure remains the same.
Examples of rotational symmetry. This is an image of an ice cream cone. Let's see what happens when we rotate this image through an angle. Note carefully that on rotation, the image looks different. It does does not resemble the original image at any point during the full through.
Could you see that? When we are talking about rotational symmetry, it basically means even if we are rotating the figure through some angle, it should resemble the original figure, like we had done for the rectangle. On being rotated through 180 degree, the figure remains the same. But here, this ice cream cone, when rotated through 90, does this and this figure same? No. So this figure is vertical like this. We have the ice cream at the top and the bottom cone is at the here. But here see the ice cream is at the right side now. Yes or no? So this figure and this figure is not same. That means on rotating this ice cream cone through 90 degree, the original ice cream cone and the rotated one is not looking the same. So what we can say? It does not possess rotational symmetry. Also we have a term called as order of symmetry. That also is there. We will learn about that also. Order of symmetry means how many times you can rotate the figure to get the original figure.
60-degree rotation. Therefore, this figure does not have rotational symmetry.
I hope it's clear to all. So not only 90, if through 180 we have done, through 270 we have done, only through 360 we have done, then the figure remains the same. Yes or no? So if we rotate through 360 means what? The same figure as it was originally.
The unicycle is a good example of rotational symmetry. Let's give the wheel a little push so that it rotates.
If you see this unicycle, or you can say it is a tire or a wheel only, if it is rotating at any point you stop it, it will look like the same only. That means to all the angles it has got order of this symmetry on all angles.
Notice that during rotation, the object rotates around a fixed point.
So could we say that this unicycle is rotating about a fixed point? Yes or no? The point where the axle passes.
The fixed point around which the unicycle is rotated is called.
So see, we had in a point symmetry a center, and here also there is a point around which the object is rotating, and that is called as center of rotation.
The center of rotation. Rotation may be clockwise or anti-clockwise. A full turn refers to a rotation of 360 degrees.
Okay, full turn is completely through 360 degree, completely it's turning around.
A quarter turn refers to a rotation of 90
This
degrees.
is 90 degree.
While a half turn refers to a rotation.
So half turn is the sum of angles around the point is 360, half of which is what? 180. So half turn is 180. Quarter turn is 90 degree.
Rotation of 180 degrees. Now, take a look at this card. Notice that the card looks different at every.
Can we say it has also got the same condition like the ice cream cone? The figure, original figure, and at 180 degree also, so not the ice cream cone directly. At 360 it is the same, and at 180 also it is the same. So we can have some angles where the figure looks like the original figure only.
The angle it is being rotated. However, at half turn, it looks the same. Therefore, it has rotational symmetry. The angle at which a shape or object looks exactly the same during rotation and
That means if at all exists some angle on which if we are rotating the figure through and the original figure and the rotated figure looks same, then we say that that particular angle is angle of rotation. In this case, if we rotate the card through 180, the original card and the rotated card is same. So we can say that 180 degrees is angle of rotation. So we must find symmetry between the original figure and the rotated figure.
its original position is called the angle of rotation. Let us now look at another
have drawn ABCD to show that yes, actually we are rotating it. Okay, so if we are rotating through 90 degree, what will happen? B will come down, C will go here. Okay, that's why they have given the name. See how they are rotating.
Through 90 degrees about a fixed point. The image looks exactly the same at all four positions. So, this image has a rotational symmetry of order 4 about.
Now see, whether we rotate the figure through 90, through 180, through 270 or through 360, the figure remains the same. The figure looks the same, and that is what we say. That means there are 4 angles possible through which, if we are rotating the figure, it looks the same. So if it looks the same on rotation through all these 4 angles, the order of symmetry is said to be 4.
Out of center. The order of rotational symmetry can be defined.
So I told you the term order of symmetry. Order of symmetry is what? It is a number only. Order of symmetry is a number only. It which tells how many times we can rotate a figure in a 360 degree complete swing, and even if you are rotating it, the figure looks like the original figure only.
As the number of times a shape appears exactly the same during a full 360 degree rotation. Let us observe rotational symmetry in a square. We have a square with C as one of its corners. The center of rotation is the center of the square.
Now
We should
we
now
see
turn the square through none.
we have for the regular geometrical shapes so many symmetry orders. So for that, orders have to be learned also, and if you are understanding it, it's also okay. But again, these orders could be asked to fill in the blanks, MCQs or true false for this thing they can be asked.
50 degrees above the center O. The angle of rotation is 90 degrees. The direction of rotation is clockwise. Note that at every 90 degree turn, the square looks the same.
So for all the 90 degree turns taken, one time 90, then 180, then 270 and then 360. So at all the turns taken, the square resembles the same. That means again, it will have order of symmetry 4. But did we observe the same thing for that playing card also? No. Only one angle was there. Once through 180 degree we are rotating, then. But at 90 degree rotation, that card was not found to be symmetrical. But the square is.
In a complete turn of 360 degrees, the square looks the same 4 times, so it has a rotational symmetry of the order 4. The kaleidoscope contains a magical world inside it. It is a tube
This is a kaleidoscope. You must have learned in physics also about it.
made of mirrors inside so that they create reflections of different types of patterns. A circle has infinite lines of symmetry.
That means at any line if you draw, that will be a line of symmetry for the circle.
If a circle is rotated around its center through any angle, it looks exactly the same.
Just like that giant wheel, any angle you take, that angle will be making the figure symmetrical only. That means it will look the same even if through any angle we are rotating it.
There are many shapes that have only line symmetry and no rotational symmetry at all. Let's take
So it may happen that a figure has got line symmetry also, point symmetry also, and rotational symmetry also. So depends on figure to figure. That thing we have to learn, or by observation also we can understand.
Take a look at some of them. Interestingly, some objects and shapes have both line symmetry as well as rotational symmetry. Did you know that the Ashok Chakra in the Indian flag has both line symmetry and rotational symmetry?
Now see, Ashok Chakra, it's a circle only. It has got which type of symmetry? Line also and rotational also. That's what I was telling you, that some figures can have both types of symmetry. Linear also and rotational also.
Tree. Symmetry can be seen in the ink.
For the letters, Already you have done in class 7 also, it's just a revision only.
English alphabet as well. Here are some capital letters of the English alphabet. Let's take H as an example. If we fold the letter H horizontally from the middle,
So if you are folding it, does it coincide with the remaining half? It does. That means along that line it has got linear symmetry.
all the lines overlap. This shows that the letter H has line symmetry. Let's now rotate letter H. Notice that H looks the same at a 180-degree rotation, and so it has rotational symmetry as well. Here's a tip.
So this table you can make in your copy also. Okay, and making it stay for some time. You can pause the video and note it down also. For letters we need to understand. And again this can be a part of your true, false, fill in the blanks, MCQs. That which letter has got both, which has got only one.
Table that lists the type of symmetry seen in some capital letters of the English alphabet. In this module, you learned.
So I hope things are clear now. That is the end of the chapter and exercises I will be sending you through the PDF only.